Thank you very much for your curiosity, even though I think I'm still, how to say, I just got graduated and I had experience in other kind of stuff, which are technical but not real engineering. But I just joined this company and I'm still learning. So this is a disclaimer that do not expect that I can deliver you an expert level idea. Anyway, uh, okay, I'm going to turn off my camera and I'm going to share my screen. So if it's visible, please let me know if you can see my screen.
Yeah.
And am I audible?
Yes.
Am I clearly audible to everyone?
Yes. Yes. We can
All
hear you.
right. So I would like to start with the question to everyone. I know you guys are very good student. You came from KNUST. I know you have those things, those basics, fundamentals. But still, it sounds naive question, but I like to ask three of you one question. That is, what do you actually feel about when in terms of manufacturing, specifically for automotive manufacturing, let's say a part manufacturing? I would like to hear three of your opinion one by one. I would like to call first Emmanuel. Just your feeling, no need to definition, just your feeling. What do you understand about manufacturing?
Okay. Okay. So basically, the idea you have about an maybe a system or a, a way of solving a problem. So the idea you have, you now produce the idea physically. So
Oh,
that is manufacturing.
okay, thank you. Okay, now Eugene, can you share your feeling about manufacturing when you heard this word? What do you think about this?
I think it's just the production of goods in large scale.
Oh, good one. Short and good one. And Joshua,
Okay, so for manufacturing, my understand as layman's opinion, I would
mm,
say an idea that is in one's mind and the person tries to document it. Then from there, it further proceeds to bring it tangible out. I mean, produce it out so that it can be felt. That's the whole concept about manufacturing. Thank you.
all right. As I expected, you guys have a good grip in academics, but I also had this same idea before going to the industry. And exactly if I say before 1 month, I had the same idea about you. But I'm not saying that I'm a very expert in manufacturing, but here's what I actually saw and understand and what my concept about manufacturing. And more importantly, I got to introduce this new term. For me, the term is new, design for manufacturing. So the two term design and manufacturing. And you don't have to worry about that. I'm going to like uh, talk. Not like that. I would like to show my real experience as far as I might be wrong, but until now, my understanding. So let me give an example here. So when we started our engineering studies, or even before that, when we heard about the word design have this word have many implementation in different domain, like for architecture, for mechanical engineering, it's different. And in terms of fashion design, it's different. In terms of artistic design, it's different. And the term, when we say the design and design for manufacturing, these are two different things. Because let's say when we see the body styling for every car, that body styling is not necessarily done by an automotive engineer. I think you know this. Don't know this thing. They are called concept designer. They don't have to deal with too much about geometry and mathematics. Of course, they have to sit down with the engineer and discuss about uh, the the physics, a little bit of measurement, but they're more focused on the aesthetics and the outlook of the car. So that design perspective is different. And then when it comes to engineering design, you may have heard some of the analysis software called ANSYS, Abacus, Hypermesh. Um, so when we call about the engineering design, we are denoting the numerical design or the mathematical modeling and functionality of a part of a system. But when we are talking about the design for manufacturing, we must have to include one thing. Of course, the objective of design for manufacturing is to manufacture the product that we have designed. Let's say an example, a concept. Let's say we want to, it seems like boring, guys, but hold on a second. I'll give you some example. Let's say we want to manufacture this bolt. Okay, this is a bolt, let's say. All right. So first, you guys know that we will, as part of the requirement, we will sketch in any CAD model, and then we will convert it to 2D, and then we will give it to the manufacturing agencies. But from the concept, the first engineering design must come from the requirement analysis. I think you guys have done the systems engineering, so you can relate that. The requirement analysis is mostly connected with the functional analysis, okay, which include the structural analyses, the stress, strain, all the engineering, mathematical modeling. So you have done it. But now, when it turned to manufacturing, that structural analysis can be changed. It's called the product life cycle. That is not final, because there is this very important distinction between engineering design and design for manufacturing. Of course, design for manufacturing is also engineering design, but in design for manufacturing, the most important thing is GD&T. It's called geometrical dimensioning and tolerancing. Okay, I'm not so expert in this. I'm also learning this one. But hopefully I can give you a good example to get this concept. And the other thing is most important, the cost, time, reliability, durability, whatever you say. So these terms are very important in terms of design for manufacturing. Okay. So I have given you a teeny bit of concept about design for manufacturing, but let me go through it with some details. So as I say, from the concept, when we design, okay, I have a question to you guys. How many of you have had this concept that CAD modeling is design engineering? Did you had this even in your bachelor or maybe in your early stage of your master's? Did you had this idea that CAD modeling is design engineering? Anyone?
Yeah, hello.
Yeah,
For
yeah, I can
me,
hear
I
you.
knew you need the card if you want to design.
Mm,
Yes, because your idea will be in your head, but the card model would make others understand.
mm.
So the card model is the basis. That's how I understand it.
Yeah, that's the same thing actually that many students have, but you give a quite a detailed thing and very formally. That's good. Good enough. But I will say no. That's the first thing that my boss made a clear distinction between CAD modeling and design engineering. Is totally different. CAD modeling, there is a saying, Elon Musk, it's a very famous saying that everything looks perfect in PPT and every design look perfect in CAD modeling. But actually CAD modeling is not design engineering. Why? Because I know many students, they can do a very good CAD modeling. Trust me, very, very good at it. But when it comes to do the manufacturing, they failed. Literally, they failed. Because they can copy, if you give them the geometry, they can copy and they can model, they will do some extrude modeling, cut, whatever it is. And it looks very perfect. But in real design for manufacturing, CAD modeling is not design engineering. It's just a tool to do the digital twin or to mimic the part for further analysis. Even for a simple bolt, when you are assigned to do a simple, I don't know who is calling me. Oh, he called me in the wrong time. All right. Okay. So when you are responsible to manufacture just a simple bolt, you can feel that time how much challenges are there. From the concept to design CAD modeling to design for manufacturing and finally QC and then finished product. It's a very, very challenging task. Just a simple screw, just a simple bolt, because when you do the CAD modeling, it seems, okay, I have done this modeling. And many students can do this. Even many students can do better CAD modeling than many of the real engineers. That's true. But if those students are assigned to do the manufacturing, the real manufacturing, not the school project, like Joshua did, I respect that. but it doesn't have one factor, and that is called production time and cost. It doesn't have it. The real production time and cost scarcity can only be filled in the real engineering project. I would like to share one of my situation right now. Recently, the project that my boss gave to me, it seems very, very simple. The task is someone already have did the 3D and 2D. I have to check if the 3D and 2D's dimensions are correct. Now it sounds very easy, but if I do a slight mistake, just maybe some part which has a precision, high precision, and do the 0.001 difference, that can cost a lot of money. And I'll be responsible for that. So the challenge is precision, and as like Eugene mentioned, a very important thing, that is the larger scale manufacturing. The challenge comes with the large scale manufacturing and at the right time production. Because when you produce, the product has to be QC passed. And then the product might be manufacturing in China, but it has to reach in Accra, let's say. And there is some guy who is waiting for the product because he also have to distribute this product throughout the market. So many challenges are associated with this thing. Just a slight 0.001 tolerance can make a bigger mistake, and even sometime, as my boss say, for a software engineer, one simple coding mistake can sink the whole ship of the business. And for mechanical engineer, for simple design mistake can bring a big disaster. I think you guys can feel right now, right? It's very challenging. It's very challenging. I'm saying this to you, even for screw design. And what is the distinction between the design for manufacturing and CAD modeling or whatever it is. It's called the GDNT, dimension tolerance. Okay, so what is GDNT? Do you have any idea, like prior idea about it? Okay, if you don't have, it's not a big deal. I also got used to introduce it right now. So I'm going to open my CAD. Let me ask you a question, guys. Are you guys feeling boring? Something like that? I'm not a good lecturer.
Oh, we are listening.
Oh, we are okay. We are listening.
All right. Thanks. Thanks for listening to me. Okay, so we can see that a connecting rod, this connecting rod, I actually designed it during my practice. I don't have any real business with this thing. I was just practicing mine. It seems very, very, very perfect. You see, it's very perfect, and it's ready to manufacturing. Seems like that. When I was doing, I was feeling like that. Oh, I become a real automotive engineer. but but see, you know that if you guys are familiar with CAD modeling, you know that there in CAD modeling software you have part design workbench and assembly design workbench, right? Drafting workbench, many many more. So it seems perfect when I did the part design, but this part has to be assembled with some other part. Like I have to assemble this connecting rod, this small end bearing with the piston, gauge and pin, and this big end bearing with the crankshaft. Now imagine this gauge and pin hole, the big end bearing, sorry, the small end bearing. It's called bearing. That's mean it's beer loads. And when I insert the pin here, of course the pin is not fine-tuned because not many manufacturer can use CNC machine or laser cut or hydraulic cutting machine. These precision manufacturing processors are not available everywhere. Even in China, you can still see some manufacturing processes, a traditional lathe machine. They're doing some basic machinings and then they're exporting this part to according to the cost and requirement. So high precision is not there. So if you do some mistake, then this bearing can cause the mating, and the bearing can cause a lot of trouble, and your customer will complain to you because it's ultimately affecting their product. Suppose you're supplying to an automotive OEM as a connecting rod manufacturer and you did some mistake because the section, every section is not precisely same in the piston pin. So that's why let me give you an example. Oh, where is the PPT? Okay, let me draw the piston pin. Let's say this is the piston pin. In every section, the piston pin is not absolutely geometrically equally constrained, right? Somewhere it's got maybe 0.001, 0.002. This kind of differences will be there. So, on the other hand, you have this connecting rod where the pin will get assembled. Okay. So you have to put a certain limitation where the lower limit and the upper limit can fit into the connecting rod, and that's called the tolerancing. So if the tolerancing, if the diameter, let's say the piston pin diameter is, let's say 25 mm, let's say when we add 0.05, that's mean the machinist can understand that this pin I can alter between 25 mm plus 0.5. That's been 25.5 or 24.5. This is the maximum and minimum limit, and this is called tolerancing. You attach a tolerance. In every assembly, remember this one, in every assembling point, every assembling unit, this tolerancing is very, very important. And the dimension, it's simple. Center distance, any dimension. I will give you a very real example a couple of minutes later. So that's called the geometrical dimensioning and tolerancing. So, but the tolerancing has its norm according to different organization. Just like in engineering drawing, we have some rules, right? Of course, you can do the dimensioning without tolerancing, but that's not a standard. Machinists will often fail to produce your design product. So when you do the CAD modeling, you have to think like that. You are a machinist, you have a lathe machine in front of you, and you are cutting that part just as same as like machinists do, so that you can feel the machinist and his perspective. And the GD&T is a language between an engineer and a machinist. And that's just a small part of design for manufacturing. If the manufacturing process is changing, then the design will also change. Okay, so I will give you an example. Let's say I finish this 3D, okay? Now I want to, if I give this 3D, that's not going to be okay for the machinist. We have to give the 2D engineering drawing. So in CATIA, you can go for drafting. And I think you guys are familiar with this thing, because in engineering design, we have different rules, right? So according to the sheet, you can choose your sheet. I'm just choosing one just to elaborate. So I will fetch up this. Let's say I will take this portion. And right now, I'm actually doing the 2D thing, and it seems easy, but it's quite difficult because you have the dimension with it. So we got the, let me change the scale. Let me put it 6. Maybe it's okay, yeah. And I think you guys can remember your first year of your engineering college. You have to, carry the T scale and draw the engineering drawing classes. This is the real engineering sheet, but in CAD. Anyway, so you see, so what I'm doing is like now it's just giving a dimension here. See, just a dimension, 250. Okay. So the machinist can understand the difference between the center point of here, but maybe you can give more detail. Maybe you want to give more detail. Okay. Yeah. Okay. Now, when you see this mark, okay, it's represent the diameter. This is also GD&T. This is also GD&T, because GD&T has two parts. One is the dimensioning, and the second one is tolerance. So let's say I want to give a tolerance, and you have many kind of tolerancing system, and I put this one, and I want to make understand the machinist that when he will bore this one, and while he's doing the machining work, he can alter ±4. I don't know why the plus minus is not. I don't know what happened, because in my machine there's sometimes some problem happens. Let me change this one and see. Nope. Anyway, there should be a plus minus mark over here. Okay, so this is called the GDNT. All right, so do you guys have any question? This is all about I wanted to present. And if you don't
Okay.
have any question, I will go to the second part of today's session, is like the job things with CATIA or any other CAD modeling here in China. All right, maybe someone wanted to tell something. Yeah, I interrupted.
I think you can go on.
Okay.
I don't have a question.
Okay, great. So, as in the group that I mentioned, that if you want to find a job in China, you can choose design for manufacturing, CAD modeling, because that's an easy thing to do so. And I know, because I know you guys you will face some confusion when you will choose when you will go for your career, because some of you will ask yourself, should I go for this CAD modeling stuff or not, because I'm doing the control design or something else, maybe thermal design. But trust me, CAD modeling or this design manufacturing processes, this kind of jobs are quite easy to get, especially in our city. But the only obstacle you have to face is the Chinese ability. You have to have a good ability in Chinese. What I mean by good ability is not that you have to speak very fluent, like maybe like innocent. No, the intermediate skill is quite good enough, because you can still use the translator. But for at least you have to know the intermediate Chinese. Okay, and you can use the Boss app. There is an app, and in the Boss app you can see many jobs there. You just have to make your profile a good profile there, upload your profile. So my whole purpose is to tell you that there is a scope for design for manufacturing job in China, and that's big amount of jobs are there. A lot of jobs are there, because these positions are actually empty, because if any fresh graduates are coming, they're leaving the job right after 1 or 2 year. So I think we just have a 20-second. If you guys have any question further, I don't know if this session is beneficial for you or not, but if you still have any question, you can directly ask me, or maybe sometimes in some other time we can arrange another session. I think we just have 8 second or 7 second. Until then, take care everyone. Bye bye.